and in this video I'm going to discuss 5 physics problems of AAI ATC Shift 1 paper. I hope you will enjoy it, and if you like it, please press the like button and share and subscribe if you like this kind of videos. In this video I'm going to discuss 5 physics problems of ATC 2021 Shift 1 paper. So in the 16th problem it has been said that an energy flask of 18 watt per centimeter square falls on a non-reflecting surface which has an area of 20 centimeter square. We need to find the total momentum deposited. So we need to find the total energy deposited by the photon, which is the energy flask times the time of deposition, that is 30 into 60 seconds, that is the total energy deposited per centimeter square. Now we need to multiply the area, which is 20, and we know for photon energy is momentum times speed of light, so P is E by C, and that is 18 into 2 into 10 to the power 3 divided by 3 into 10 to the power 8, and the answer, if you calculate it, would be option D. Now question number 17 says that the following velocity and time graph of the ball of mass 250 gram rolling on the concrete floor, compute the acceleration and frictional force. Now for the rolling motion, the only horizontal force that acts on the system is the frictional force. So basically first we need to find out the acceleration from the graph. So acceleration from a VT graph is basically the slope of the curve. So if this angle is 180 degree minus theta, this angle is theta, and the acceleration is basically tan 180 degree minus theta, which is minus tan theta, which is equal to minus 80 by 8, that is minus 10 meter per second squared. So now the force is m times the acceleration, which is 250 into 10 to the power minus 3 kg into the acceleration, which is basically the answer is not matching, because the answer would be 25 times 10 to the minus 1, that is 2.5 Newton with a minus sign, because the acceleration is negative. So none of the answer is matching. This is the closest one, B. So B is the probably right answer. So now the 18th question says that particle of 15 kg is moving under a constant acceleration starting from rest. Find the momentum and the velocity as per the table below. So we need to use the formula of kinematics. P is U plus AT. Now U is 0, so A is 3, so V is 3T. So as the given time for 0.5, 3 into 0.5 is basically 1.5 meter per second. All are in meter per second, and now 1.5 is 3 times of 0.5, so basically that would be 4.5, and 2 is basically 4 times the 0.5, so that would be 6.0, and 3 is basically 2 times 1.5, so you need to multiply 2 to this number, that would be 9.0. So as you can see, 1.5, 4.5, 6 and 9, these two answer matches with them, so we need to calculate the momentum only for the third option, because it is different in option A and option C. So the mass is 15 kg, 15 into 6 is 90, so the momentum for the time 2 seconds is basically 90 kg meter per second. So option C is correct answer. You do not need to calculate the other momentum, just be little careful and observe the options first. How to solve this problem? It is given that a parallel plate capacitor made of circular plates, each of the radius is 6 cm, has a capacitance 100 picofarad. The capacitor is connected to a 230 volt AC supply with a angular frequency 320 radian per second, what is the RMS value of conduction current? So as I know from the Maxwell's equation, the conduction current is, or any current is, the area, cross-sectional area times the current density J. Now from Maxwell's equation, we know the conduction current density is basically epsilon naught times dE dt. For parallel plate capacitor, the electric field is basically A epsilon naught d dt of sigma by epsilon naught, where sigma is the charge density. Now since epsilon is a constant, I can cancel out the epsilons here and here, so I will have the area, which I can now write as pi r square into d dt of sigma. Since pi r square is also a constant, I can take them into the derivative. So that would be d dt of pi r square sigma, which is d dt of the charge on the plate of the capacitor. Now as we know, the famous relation that charge on the plate of capacitor is capacitance times the voltage across its plates. So we can use this relation. Since the capacitance is a constant quantity, dq dt is basically C dv dt, right? Now we have to remember this 230 volt AC supply. This 230 volt is basically the RMS value of the voltage supply. So as we know, for AC current, the voltage is written like this: V0 sine omega t, right? This is the peak value, this is the angular frequency. So if you write dv dt, which is V0 omega cos omega t, now the RMS value of dv dt is basically V0 omega and the RMS value of cos omega t, which is basically root 2. So this is V0 by root 2 into omega. Now we know V0 by root 2 is basically the RMS value of V. So V RMS times omega. Now current RMS value is the RMS value of dq dt is C times dv dt, the RMS value, which is basically C times omega times V RMS. C is 100 picofarad, that is 100 10 to the minus 12. Omega is 320. V RMS is 230, and if you calculate this, you will get 7.36 microampere. For the 20th problem, the problem says which of the following statement is correct regarding the locus of a point on this plane, that means the plane of the paper, where the potential has a 0 value if two electric charges q and minus 2q are placed at a distance 6 meters apart on a horizontal plane. So for this, we are going to assume that the one charge, that is plus q, is at the origin and the minus 2q is at 6, 0. So the net potential at any position x and y is written as 1 by 4 pi epsilon 0 q divided by rho r x square plus y square, that is the distance of the point from the origin, and the distance of the point from minus 6, 0 is x minus 6 square plus y square that is equal to 0. So squaring both sides, you will get x minus 6 squared plus y squared is 4 times x squared plus y squared. So if you rearrange, so one of the x squared and y squared will cancel one of the x squared and y squared on the RHS. So we are taking everything on the right hand side, so you will get 3x squared plus y squared, and here on the LHS you have a 12x with a minus sign. On the RHS it will be plus 12x and minus 36, that is equal to 0. So x squared plus y squared plus 4x minus 12 is 0. So as you can see, you can add and subtract 4. So and then you will get x plus 2 whole square plus y square is 16, which is 4 square. So that is an equation of a circle which has a center at minus 2 comma 0 and a radius 4. So option A is the correct answer.